You're standing on a planet. That planet is spinning at over 1,000 miles per hour. It's orbiting a nuclear furnace 93 million miles away. That furnace is just one of hundreds of billions of stars inside a galaxy. And that galaxy is only one island in a cosmic ocean stretching 93 billion light-years across. Most people look at space and see beauty. Glowing nebulae. Perfect spiral galaxies. Black holes wrapped in elegant rings of light. It feels calm. Peaceful. But the universe is not calm. It is violent. It is unstable. And in some places, reality itself begins to fall apart. Tonight, we're not visiting the prettiest corners of the cosmos. We're going to the places where galaxies vanish. Where gravity tears atoms apart. Where regions of space shouldn't exist, but do. And the most unsettling part? Some of it is happening in our cosmic neighborhood right now. Let's start with nothing. Real nothing. About 700 million light-years away lies a region known as the Boötes Void. It stretches roughly 330 million light-years across. To understand how massive that is, imagine placing the Milky Way inside it. You wouldn't see another major galaxy for hundreds of millions of light-years. A region that size should contain thousands of galaxies. It contains only a few dozen. Astronomers discovered it in the early 1980s while mapping galaxy distributions. They noticed something strange, a massive gap in what should have been a crowded region of space. Gravity is supposed to pull matter together over billions of years. Space should become structured, clumpy, rich with galaxies. Instead, this region remained eerily empty. Scientists believe smaller voids may have merged together over time, forming this enormous cosmic bubble. But that explanation feels incomplete. Because emptiness on that scale should not remain stable for so long. And yet it does. The Boötes Void isn't terrifying because it's empty. It's terrifying because emptiness that large challenges our understanding of how the universe organizes itself. Now let's go bigger. In the faint afterglow of the Big Bang, the cosmic microwave background, astronomers discovered something colder than expected. A vast cold region imprinted on the oldest light in existence. It's associated with what we call the Eridanus Supervoid. Nearly 1 billion light-years wide. The idea is that if light from the early universe passes through a region with fewer galaxies, it loses less energy interacting with gravity. The result appears slightly colder. But here's where it gets uncomfortable. Some researchers argue the supervoid alone may not fully explain the temperature anomaly. Which raises deeper questions. Did something influence that region before cosmic inflation settled? Could there be large-scale structures beyond what we can observe? Are there aspects of cosmic physics we haven't discovered yet? When the oldest light in existence behaves in ways we don't fully understand, it suggests our model of the universe may be incomplete. And that's far more disturbing than empty space. Now consider motion. Our galaxy is not drifting aimlessly. The Milky Way, along with hundreds of thousands of neighboring galaxies, is moving at roughly 600 kilometers per second towards something we can't clearly see. It's known as the Great Attractor. We discovered it by measuring galaxy velocities. Something massive is pulling everything in its direction. The problem is, it lies behind dense dust and gas in our own galaxy, obscuring direct observation. We detect it by its gravitational influence. Like watching objects slide across a table toward an invisible magnet. Later research revealed something even stranger. The Great Attractor itself appears to be part of an even larger gravitational structure known as the Shapley supercluster. We are being pulled towards something that is itself being pulled towards something larger still. Its gravitational hierarchy on a scale almost impossible to visualize. We exist inside a vast cosmic current. And we have no say in where it leads. Now let's talk about something visible. Black holes. When a massive star collapses under its own gravity, it can compress into a region so dense that escape velocity exceeds the speed of light. The boundary surrounding that region is called the event horizon. Cross it, and there is no return. From an outside observer's perspective, time appears to slow dramatically near the event horizon. From the inside, space curves so intensely that every possible path leads inward. Objects falling into a black hole experience extreme tidal forces, stretching in one direction and compressing in another. This process is sometimes called spaghettification. At the center lies something even more extreme. A singularity. A point where density becomes effectively infinite. Where space-time curvature becomes infinite. Where our equations stop working. General relativity predicts singularities must exist inside black holes. Quantum mechanics cannot fully describe them. We have mathematical evidence that they form. But we cannot explain what they are. They are not simply unknown. They may be fundamentally unknowable. At the center of our own galaxy lies Sagittarius A star. A supermassive black hole containing about 4 million times the mass of the Sun. It sits roughly 26,000 light-years away. In 2022, astronomers captured the first image of its shadow. Proof that the gravitational giant at our galaxy's core is very real. Its event horizon spans about 27 million kilometers. Compressing 4 million suns into that volume is difficult to comprehend. Right now, Sagittarius A* is relatively quiet. But if enough matter fell into it suddenly, it could become active, emitting intense radiation. Gamma rays. X-rays. Relativistic jets extending across light-years. We live in a galaxy with a sleeping gravitational engine at its center. And sleeping engines can wake. In the early universe, many supermassive black holes were not quiet. They were quasars. Extremely luminous galactic cores powered by rapidly feeding black holes. Some quasars emitted more energy than 1,000 Milky Ways combined. Matter spiraling inward forms an accretion disk, heating to millions of degrees. Twin jets can blast outward across intergalactic space. If a quasar were close to Earth, its radiation could strip away our atmosphere. Sterilize the surface. Erase life. We are fortunate that most quasars are billions of light-years away, relics of an earlier era. But they demonstrate what black holes are capable of when actively feeding. They are not just gravity wells. They can become cosmic beacons of destruction. Then there are magnetars. A rare type of neutron star with magnetic fields trillions of times stronger than Earth's. Strong enough to distort atomic structures. In 2004, a magnetar flare from 50,000 light-years away briefly disturbed Earth's ionosphere. If that flare had been significantly closer, satellites could have malfunctioned. Power grids could have been disrupted. Magnetars are unpredictable, violent, and scattered throughout our galaxy. They are essentially cosmic magnetic weapons. Now imagine something worse. A black hole that doesn't stay at the center of a galaxy. A rogue black hole. These objects can be ejected during galactic collisions or stellar explosions. They drift through space, invisible. Undetectable unless they gravitationally distort background starlight. There could be millions of them in the Milky Way alone. If one passed near our solar system, it could destabilize planetary orbits. And we might not detect it until gravitational effects were already underway. There would be no visible warning. Just subtle orbital shifts, and then chaos. In 2008, scientists studying data from NASA's WMAP mission observed something unexpected. Galaxy clusters across billions of light-years appear to be drifting in the same direction. Toward something beyond the observable edge of the universe. This phenomenon is known as the dark flow. If confirmed, it suggests gravitational influence from structures beyond what we can see. Beyond the cosmic horizon. Beyond the limit of light itself. We don't know what lies there. But something may be tugging at our entire observable universe from outside our field of view. Finally, consider the edge of what we can ever know. The observable universe extends about 46.5 billion light-years in every direction. Beyond that, light has not had time to reach us since the beginning of cosmic expansion. But space continues. Galaxies near the edge are moving away so rapidly due to cosmic expansion that one day, their light will never reach Earth again. In trillions of years, distant galaxies will fade from view. Future civilizations may look up and see only darkness. They may believe they are alone. We live in a rare cosmic era, when the universe is still visible in extraordinary detail. But that visibility is shrinking. The scariest place in the universe isn't a single location. It's the pattern. Voids that shouldn't remain empty. Forces we cannot see but feel. Singularities where physics collapses. Motion toward destinations we don't understand. The universe is not built for comfort. It is vast. It is indifferent. And it hides most of itself beyond permanent horizons. We are on a spinning rock, orbiting a star, inside a galaxy being pulled toward something invisible. Surrounded by structures we barely comprehend. And every discovery reveals deeper questions. The universe isn't just dangerous. It's unknowable. And that might be the most unsettling truth of all.